Hello YouTube, my name is Musa and welcome to Engineering Tech. In the previous video, we dealt with grade 11 mathematics doing exponential laws. In this video, we're going to be continuing with the correlations or the dependencies coming from those laws, and then we'll do a few examples. So let's get to it. The first correlation that I'm going to talk about is a correlation that states that any number to the exponent of 0 is equals to 1. Now, how do we prove this? This is how we prove it. From the division law, we know that any number to the exponent divided by another number to the exponent, you subtract the exponent, right? And now let's look at it this way. If I have the same number to the same exponent divided by itself, it would be a to the exponent of that number minus itself, which is 0, right? A to the exponent of n minus n is 0 from that. Now, from algebra, we know that if you are dividing a number by itself, you get 1. So this from algebra would be equals to 1. So if from algebra we get it as equals to 1, and then if we apply exponential laws, we get it as a to the exponent of 0. It just simply means a to the exponent of 0 is equals to 1. That's the first correlation. Second one is a very obvious one. It states that if I'm raising 1 to any exponent where the exponent is an element of real numbers, then the answer will still be 1. Remember, real numbers are all the numbers from 1 going to the positive, counting in increments of 1. So 1 to the exponent of 1, 2, 3, 4, 3,000, 5,000, all those will still remain as 1 as the answer. The other one is one that goes both ways. It says if I have x to the exponent of negative, then I can write this as 1 over x to that. So this just simply means if I have any number and then I convert if I have any exponent and I convert the exponent to a fraction where the exponent goes to the denominator, the sign of the exponent changes, right? So in the same sense, if I have x to the n, if I want to write it in fraction form, I can write it as 1 over x to the negative n. So every time when I move an exponent from one side of the fraction to the other, either from numerator to denominator or from denominator to numerator, the sign changes. In the same sense, if I'm moving this exponent from the numerator up to the denominator where it's going to become x, the sign changes, so it becomes x to the exponent of n. So switching the fractions, switching the side of any exponent changes the sign of the exponent. The next correlation we're going to talk about is one that is related to coefficients, right? Remember in the previous correlation, I talked about something that is x to the negative n being equals to 1 over x to the n, right? Now let's say this thing was multiplied by some coefficient there. What happens? It's still the same thing. In the previous one, the coefficient of the thing was 1. In this sense, the coefficient is 2. And then here's what happened. In the previous one, we kept 1 at the top and moved just the exponent. The same thing happens in this case. You keep the coefficient at the top and you move the exponent. So in this case, 2x to the exponent of negative n can be written as 2 over x to the n. So you just move the exponent and leave the coefficient in its position. The other correlations are correlations that can be derived from the previous correlations that I've shown you, where if you have something like 1 over x to the negative n, it becomes x to the n. This is the one that talks about switching at the sides of the side of your exponent, and then that's switching the sign itself. So we're going to skip on those, and those are easy to understand, as you will see in the table that I've shown you. The other correlation that I want to talk about is one where it talks about switching that, but instead of switching one exponent, you're switching any or all the exponents. So say I have something that is like a to the exponent of negative m divided by b to the exponent of negative n. So if I switch b to become a positive exponent, I'm going to take it to the top, and it becomes just positive n. And if I switch a to become a positive exponent as well, I'm going to take it to the bottom, where it's going to be to the positive m. So switching the sides of your two exponents changes the signs of that. Again, derivative of the other correlations. Now, let's look at a few examples on exponent. The first example says if you have something that is 2a squared times 3a to the exponent of 3 times b to the exponent of 0, then how do you resolve it? Now, if we remember from algebra, we said you must group like terms, right? When you're having something complicated like that, you group the like terms. What are our like terms in this case? We have the numbers, which is 2 and 3. We have our a, which is a squared and a to the exponent of 3. And we have our b, which is just the one on its own, like so. So by grouping the like terms, it's going to make it easier to solve. So what are we going to have? We're going to have 2 times 3. These are the like terms, right? Times, and then what we're going to have is we're going to have a squared times a cubed, right? Times, and then we're going to have the b to 0. So now if you have it like this, it becomes easier to solve, because you can solve what happens here, then solve what happens there, and then solve what happens there, and then you just simplify the final answer. So let's look at it. Now what do we have? 2 times 3 is 6. So we have 6 there. And then here we have 2 numbers with the same base, so multiplied, so we add the exponents, right? This is the multiplication law. So we're going to have a to the exponent of 2 plus 3. And then we have a number to the exponent of 0, which is equals to 1. So in this case, we're going to have it as 6a to the exponent of 5 times 1, which remains the same. And this is your answer. So you see, you just follow the exponential rules, or as well as all other algebra rules, and then you'll get to your answer. Let's look at another example. Now this example includes a bracket. So let's look at it. It goes this way. Negative 3a to the exponent of 3 times b all to the exponent of 2 divided by a to the exponent of 5 times b to the exponent of 3. Now in this case, again, you group your like terms. You have to identify what looks alike and what doesn't. So in this case, the 3 is on its own, and we have 2 a's and we have 2 b's, right? And then they're aligned like so. Now let's see what happens. What do we have first? We have a bracket. So we can apply the bracket law, where we multiply this exponent into all the other exponents inside of your bracket, right? And remember, the exponent multiplies all exponents. So what you will have is you will have negative 3 squared times a to the exponent of 3 multiplied by 2 times b to the exponent of 1 multiplied by 2, all divided by a to the 5 times b to the 3. And then you simplify there. What you're going to have is 3 squared is 9, right? And then what this gives you here is 3 times 2 is 6, right? And then what you're going to have is going to move a over a to the 6 divided by a to the 5, which is going to be a to the exponent of 6 minus 5 times, and then you're going to have b, this is 2, so you're going to have b to the exponent of 2 minus 3. So the simplification of this is going to be something like this. You're going to have 9 times a to the exponent of 6 minus 5 times b to the exponent of 2 minus 3. This becomes 9 times a to the 1 times b to the negative 1. And then now remember, any number that is to the exponent there, you can write it as 1 over. So you can have it as 9a to the exponent of 1 divided by b to the exponent of positive 1, like so. And this is your answer. Let's look at the last example. Now this example is a bit complicated. It's this way. It goes 2 to the exponent of x, 2x to the exponent of 3, all to the exponent of negative 3, like so, divided by 8y to the exponent of minus 4, all to the exponent of 3 minus 3 again, right? So first of all, since both of these are to the exponent of minus 3, we can write it as 2x to the 3 divided by 8y to the minus 4, all of it to the exponent of minus 3, like so. And then that is the simplification of. So this and that are the same thing, right? And then remember, the exponent that is outside is going to multiply into the exponents that are inside. So you're going to multiply into those, right? Now, let's see what happens. At the top, I'm going to have 2 to the exponent of negative 3 times, and then it's going to be x to the exponent of negative 9. 3 times negative 3, right? Divided at the bottom, I'm going to have 8 to the exponent of negative 3 times y to the exponent of positive 12. Because I have negative 4 times negative 3, negative becomes positive. 4 times 3 is 12, right? That's what you get. But another way of looking at this now is to do it like this. Since you have 2x to the 3 all to the exponent of negative 3 divided by 8y to the minus 4 all to the exponent of minus 3, like so. What you can do is you can flip these two to make these two exponents positive, right? So you will have 8y to the minus 4 all to the exponent of 3 divided by 2x to the 3 all to the exponent of 3. Now the two exponents have become positive. Either you solve it this way or you solve it this way, you will get the same answer at the end. Let's simplify. Now what you're gonna get here now is an answer that is a bit complicated, a bit weird sometimes, but let's soldier through. If I multiply this in, I will have a to the exponent of 3 by y to the exponent of negative 12 divided by 2 to the exponent of 3 by x to the exponent of 9, right? Same thing. And then now the negative exponent, I move it down to the bottom. So I can have this as 8 to the exponent of 3 divided by 2 to the exponent of 3 times x to the exponent of 9 times y to the exponent of 12. And you have it like that. So what you get now is you have these two as numbers that can be simplified somehow. And then you have these two that there's nothing that you can do between the two. So now let's look at it. 8 is actually 2 multiplied by itself 3 times, right? So 8 is equals to 2 times 2 times 2, right? Which means 2 to the exponent of 3, 2 to the exponent of 3 is equals to 8, right? Now I have 8 there, so I can write that number. I can write this 8 as 2 to the exponent of 3, and then I'll simplify from there. Here's what you get. It becomes 2 to the exponent of 3, but the 8 was already to the exponent of 3, so it becomes all to the exponent of 3 like so, divided by, and then you have another 2 to the exponent of 3, x to the 9, y to the 12, like so. And then if I multiply this here, it's going to be 2 to the exponent of 9. Right? Right. And then, now that I have it as 2 to the exponent of 9, I will have, if I do the division rule between this and that, I will have it as 2 to the exponent of 9 minus 3 divided by x to the 9 times y to the 12. You see that? And then now I can just simply simplify that, which becomes 2 to the exponent of 6 divided by x to the 3, x to the 9, y to the 12. And then 2 to the exponent of 6 is 64. This x to the 9, y to the 12, and this is your final answer. So you see, you have certain ways of going about it. Either you can just simply use a calculator to calculate what's the value of 8 to the 3 and calculate the value of 2 to the 3 and divide the two numbers. Or you can take the exponents way by looking and seeing whether we have a common base, of which in this case was 2, where I can write a as 2 to the to some exponent, and then I have this as 2 to some exponent, and then apply exponential laws, which usually is the case because they say calculate without using a calculator. So if they say you don't have to use a calculator, you shouldn't use a calculator in the rules, then you would follow this procedure that I've followed here. But if they don't stipulate whether or not you use a calculator, then what you can do is just simply use a calculator where you can simplify and get to the answer a little quicker. That's it for this video. I hope you enjoyed and you learned something. In the next video, I'm going to be doing more examples on exponents, and then we're going to go into surds. Please like and comment on the video, share it with your friends and family, and subscribe to my channel. And until next time, don't stop learning.